Good afternoon. Good afternoon. My name is Shoni Boshi. So I'd like to start my presentation about my research, fuzzy control theory to resource management or virtualized system. So this is outline. First, I describe a research objective and then explain the conventional approach and the idea of our resource control and its methodology. And then after that, I show an experiment and its result. And finally, I conclude my presentation. So the purpose of this research is to propose effective resource management in a virtual system under the dynamic workload. More specifically, we have two goals. So first goal is maintaining application performance with minimal resources. Because resources on computer system is hardly limited, the resource manager provide accurate amount of resources to each domain. Second goal is balancing performance between applications. To achieve a good performance in overhaul systems, resource manager must take care of higher priority to more critical domains. So, however, the conventional approach, including the then default scheduler, allocates resource based on only virtual machines demand. This would be a problem if suppose that a virtualized system has two domains which has different performance gain for the amount of resource sizes. So even if the two domains have the same amount of resources, but in this case, right domain has a scientifically higher performance rather than left domain. So idea of our resource control is allocating resource based on relative performance. In this way, in this time, again, suppose that one virtualized system with two domains. Now, two domains which are mail domain and application domain. So now, resource manager allocate 50% of total resources to each domain. However, this time the performance is more critical on mail domain. Then controller detect this unbalancing situation and allocate more resource to mail domain and reduce the resources from application domain. Then keep the performance balanced. So let me explain the mechanism of our resource controller with an example. Suppose the virtualized system with two domains. One is a mail server and the second is the application server. First, the upper controller named QoS controller collects the QoS indicator, which is, for example, a delivery time and login successful rate on mail server and a transaction time on application server. As the second step, QoS controller collects the QoS indicator and compute a resource request. And after that, QoS controller create a request made send to arbitration controller. Arbitration controller received its request and allocates CPU time following received request. So QoS controller purposes determine the amount of resources to maintain acceptable performance. As a method, utilize the empirical relationship between performance and allocated resources. This is modeled by a fuzzy control theory, which is incorporate experiment of human process and its control design. The second controller is arbitration controller. This controller purposes the balance relative performance on domains. This domain adjusts to the system capacity and builds the resource capacity layout. For example, if the received request from domain A and domain B is 16% and 19% for each, the total exceeds the capacity of the system capacity. Then this controller recompute the amount of resource for each domain. And in this example, 40% of 60%, this the total can be 100%. In addition, commonly a resource separation resource separation is performed by creating the resource capacity for each domain. For example, in this example, we have two domains and each domain has 50% of capacity and resources separated. However, this method has some overhead, which is unused resources. Actually, the white space is unused resource because a green application has a quite higher variable overload, variable load. On the contrast, if we eliminate the capacity for each domain, the resource utilization is increased, but the degree of resource separation is quite low. So if we specify the capacity to only one domain, so this gets medium resource utilization and medium resource separation. Our controller designed these three types of resource layout. Each state changed by this state diagram. So if QoS on each domain is different, the states will be changed. To evaluate our proposed resource manager, we evaluate this resource manager on actual virtualized systems. The virtual system contains two domains, mail domain and Java application domain. Mail domain has a delivery time and login rate as QoS indicator, and the Java application domain has a transaction time as QoS indicator. Each workload to mail domain is generated by a spec mail 2001, and the Java application domain, the workload is generated by a spec JBB 2005. The physical machine has these specifications. Also, in this research, we concentrate to control CPU time, and experiment is performed with two workload scenarios. The first workload scenario, each experiment has three terms. On the first scenario, which is a mail increase scenario, began with a medium workload to each domains. At second term, only workload for mail domain is increased medium to high. After that, at the third term, the increased scenario again decreased to a medium. As the second scenario is increase the Java workload at the second term. So result is compared with without resource manager and then default scheduler. This is our mail increase scenario, and we have three results, which is the first is the first term, and second is the second term, and third term. So at the second term, in this scenario, at the second term, we increase the mail workload. So then with a resource manager, the controller detects the more critical domain, which is a mail domain, and provide more resources to this critical domain. And result, the delivery time is less than 20 seconds. Instead of that, transaction time slightly increased. However, in the case of default Zen scheduler, increase default scheduler default scheduler does not cannot detect the critical domain, so the resource allocation is not changed. So as a result, the delivery time is almost 2 times of result of with resource manager. This is the second scenario, which increase Java workload. In this case, in the case of with resource manager detects critical domain as Java workload, so it provide more resources to Java application domain, but the result is different. So means then default scheduler has a good performance rather than our proposed resource manager. So now we can see the now we want to validate the QoS controller. The QoS controller make a request follows a QoS state. So we see the relationship between QoS and resource request. So in the case of mail domain, at some point, the adaptation delay occurs. For example, the black square shows the delivery time is decreased, but the request is increased. And after that, request is decreased. So on the contrast, in low priority domain, some requests don't take account of QoS states. Actually, the transaction time is increased, but the request is decreased. So this is because our request is based on current CPU consumption. So in the low priority domain has a relative low CPU consumption because it has a low resource capacity. Next, we want to validate adaptive arbitration controller. So we see a ratio between consumption and request because this controller recompute resource from request. So then the ratio between the upper figure shows the ratio between consumption and resource request. Sorry. The upper figure shows the ratio between mail's ratio of consumption and request and Java's that. So the ratio is quite unstable. And under figure shows that each consumption, the ratio between consumption and request distribution on each case of capacity layout. This figure also shows a different capacity layout leads to a different resource distribution. As conclusion, we propose an effective resource manager, a resource which is resource allocation reflecting the application state. The experiment shows a better performance than conventional method in one experiment, which is increasing mail workload. However, a worse performance in another experiment is increasing the Java workload. As a future work, we can see the resource manager needed fast adaptation. So another solution is use a variation of QoS states as a control parameter. And also another one is dynamic rule construction because in this project, in this research, we use a fixed fuzzy rule. So we need some more flexible rule. So also, QoS arbitration controller does not perform the true fair resource allocation. So to achieve this object, we need more consideration about capping equals 0. So we need to rethink about the capacity layout, which is 3 layout. Any question?